Today we discuss Coulomb's law. Okay, so important law, Coulomb's law. So previous class we discussed what is suppose there is a attractive force and repulsive force here. Okay, and see that there is a force. So there is a get a repulsive force if they are two like charges, and if they are opposite force, if there is a opposite charges means unlike charges, so there is a attractive force. Here we discuss what is a force, how to calculate that force. So Coulomb's law state that force. Okay, and Coulomb's law inspired by Newton's gravitational law says the force F. There is a two types of charge, either positive charge Q1 and some distance. There is another charge, either it is a positive or negative, doesn't matter. The Q2, there is a force between. So that is a force F1 charge 1 due to charge 2. So Q1 experience some force due to Q2. Okay, that force means Q1 experience some force due to Q2, and similarly Q2 experience some force due to Q1. So that's called 2 charge number 2 due to Q1. These forces are vectors. Those are vectors, and they are in opposite direction. The Coulomb states that if the two charges separated by a distance r, gap is r, if I its f the magnitude that is equal to some constant k. This k is called Coulomb's constant or electrostatic force constant. This k is the constant, electrostatic constant. Constant. Okay. So here the come value of k times q1, q2, ignoring the charge either positive or negative. So just a numeric values q1, q2 by their separation square. Okay, times there is a direct there is a magnitude, so do not direct here. Okay, if there is a vector, so k q1 times q2 by r square, and that is a r unit vector. That is a r cap, and if f12, so r cap in that direction. If f21, r cap in that direction. So that a force, attractive force or repulsive force, the magnitude of force, that is some constant k times the q multiplication of two charges, ignoring the plus minus, and there is a r square, separation square, okay, inversely proportional square, okay, and that is k equal to k q1 q2 by r square. It's similar like gravitational force, Newton gravitational force. There, see that there is a small object m, there is a small m, there is a r huge m. So in case of gravitation, there is only attractive force, no repulsive force here. Okay, so only attractive force F, that is equal to g, some constant means gravitational constant, times two masses, small m, capital M is considered the magnitude, by separation is r, so that is r square, and always in that direction. Small body goes to large body, so always that direction is very important. That is only attractive force, but here comes from Coulomb's law. There is a either attractive force or repulsive force, depend on the what values of charge, either positive or positive negative, negative positive. If there is unlike charges, so there is a attractive force. If I say that is a F12, 1 2, so we get some constant k, Coulomb constant, electrostatic force constant, that is q1 q2 by r square, and F12, that direction represents, that is r12 unit vector. So R12 cap, and that is the direction of R12 magnitude. Okay. Similarly, the F21 here, F21 some constant K, Q1 Q2 by, in that direction, means in that direction R21 cap, because that is a displacement vector, and force, electrostatic force, both are in same direction. And in case of F12, that direction is R12, both are in same direction. Okay, so that is by R21 square R21 cap. Okay, so now what is the value of K? Calculate the K. Then you know that K equal to 1 by 4 pi epsilon naught. The epsilon naught is a permittivity of free space. Naught is permittivity of free space. There is some fixed value, 8.854 into 10 to the power minus 12. So their SI unit is, so if I some value of force, that is some constant. Sorry. So know the K 1 by 4 pi epsilon naught Q1 Q2 by R square. So epsilon naught equal to, so 1 by 4 pi means 1 by A. So Q1 Q2 by R square. So SI unit is 1 by 8.854 numeric value into 10 to the power minus 12. 1 by F means Newton. Per Newton, SI unit of charge is Coulomb. Coulomb times Coulomb, Coulomb square. So distance is not a meter, that is meter to the power minus 2. That's the SI unit of permittivity of free space. Okay. So that's the value. If I put that data here, so 1 by 4 for times pi 3.14 times 8.854 into 10 to the power minus 12. So we get the solve this, so we get that 9 into 10 to the power 9. Okay, so K is get 9 into 10 to the power 9. What is the value of K? If I calculate the value of K, so F equal to K Q1 Q2 by R square. So K equal to F R square by Q1 Q2. So F is Newton, R is meter square, and that is a per Coulomb, Coulomb to the power minus 2. Here put the Newton to the power minus 1, Coulomb to minus 2. Okay. So calculate the value of Coulomb constant. So hence, so there is a opposite, so there is a like charges, that's why there is a repulsive force. Okay. So now try to calculate that these magnitude are same. These force F1 to F2 are magnitude same, but they are in different. How do we calculate that? This is a vector algebra. You know that. Suppose you consider both are in opposite charges. So the first is simple, they are in opposite charges. So Q1 some separation here, that is a Q2. So force is F12 Q1 experience due to Q2, and here F2 Q2 experience due to Q1 to 1. So F12 we get, so F12 this is a vector equally represent, that is equal to some constant K Q1 Q2 by R12 square R12 cap. and F21, that is K Q1 Q2 by R21 square R21 cap. And R12 and R21 are same, because when we multiply A dot A, we get A square. Dot product of two vectors. So A cos theta, and theta is 0 degree. So A square cos 0 1. So A square. That's it. Okay. Let's say R12 is equal to R21. Now I added these two vectors. So I added these two, we get F12 plus F21 vector, we get K Q1 Q2 common by R12 or R21, both are same, square bracket R12 cap plus R21 cap. Okay, that is R12 cap, and here is R21 cap. Now to solve this from vector triangle law. So go to the next page. See that that is a plus Q1 charge, and that is plus Q2. We consider just only F1 force. If I consider just only F12 force, so that is displacement R12. So calculating start from origin O. Okay. So position vector of Q1, that is the R1 vector. Position vector of Q2, that is R2 vector. So there is a triangle A, B, O, B, and now we can apply vector triangle law. Vector triangle law, we all know that vector triangle law. So there is an algebraic sum of all vector in a closed loop, that is equal to 0. So we consider that clockwise direction is positive direction, anti-clockwise is negative. So let's say, so clockwise, so R1 is a clockwise, so R1 clockwise is positive. Let's say that clockwise is positive. If you choose a clockwise negative, that's also okay. If clockwise positive or anti-clockwise negative, or vice versa, both are satisfied. Okay. So R1 vector and R12, they are in opposite direction. You will choose a clockwise positive, that is anti-clockwise. That's a negative. So R12 and R2 also negative, because that is we choose the clockwise, so that is anti-clockwise, so minus. So R2, that is equal to 0. So R1 unit vector minus R2 vector, that is R12 vector. Similarly, alright, when you choose just only if this vector F21 vector, okay, so that is displacement. So displacement also in that direction, because force and displacement vector both are in same direction. So that is R21 vector. Similar condition, we say that clockwise is positive, anti-clockwise is negative. So R1 is clockwise positive and R21 also positive, and but R2 is negative, because R2 is anti-clockwise direction. So that is R2, we get a 0. So R21, that is equal to R2 vector minus R1 vector. So now we put R12 and R21 in the equation here. Okay. So some constant k, q1, q2 by r square. Say that r12 that is also equal to r. So r12 we get here r12 equal to r1 minus r2. R1 vector minus R2 vector, and R21 we get R2 vector minus R1 vector plus R2 vector minus R1 vector. So these two cancel. So I will get K Q1 Q2 by R square times 0 means whole 0. So finally concluded that if I added these two vectors f12 plus f21, that result is 0. Now f12 vector equal to minus of f21 vector. Okay. That means we said that two forces. Okay, if f12 or f2 are both magnitude of same, but they are in opposite direction. Okay, they are in opposite direction. So f12, so surface may be different, 2 1, but there is a minus sign. So their magnitude be the same, but they are in opposite direction. If I consider the displacement between two charges very small, which is Newton's third law, equal and opposite forces. Reaction will be action against the reaction. Okay, so if there is a action, that is a reaction for satisfying Newton's third law. If both charges are important, here is a like charges, plus plus or minus minus, they satisfied. If one is plus, another is minus, what will happen? If I consider one charge is plus, suppose that is q1 plus, another charge some distance q2 is minus, what will happen? So q1 experience some force due to q2 in that direction. So that is a f12, and with the direction of r12. Similarly, q2 experience force due to q1, that is of f21, which direction, that is r21 direction, that is r12 position vector or displacement vector, that is r21 cap. Starting calculate from origin O, that is a displacement vector actually. These two are the r1 cap and r2 cap are the position vector, and that is a displacement vector. Okay, so we know that if f12, so plus f21, what will happen? Some constant k. So q1, q2 by some r square. f12 means r12 cap, and that is r21 cap. So if I choose clockwise direction, for we consider r12 present and r21 is not present here. Suppose say that r21 is 0, not present here, it's only one charge. So we get some constant k, q1, q2 by r square. r12 means if clockwise is positive, if I say clockwise is positive, r12 minus r2. So r1 plus r12 minus r2, that is equal to 0. So r12 we get r2 minus r1. Similar that previous year. r12 we get r1 minus r2. r1 takes there is a difference. r2 minus r1. Sorry. Here we get some difference, not same. That is a difference. r1 minus r2, here r2 minus r1. Okay. Now we say that if that is for this case for R12. If you saw R12 is not here, R21 is present. So we see that clockwise is negative. Okay. So, clockwise is positive, anti-clockwise is negative. So R1 in that direction. So R12 is say that R1 is not present here. R2 is R12 is vanished. Say that R12 not here. Okay. Just R21 is present. So R1 clockwise minus R21 anti-clockwise against minus R2 is anti-clockwise. So we get minus R21 if R1 minus R2 is R1 to right side. Now there is a difference here. Previously R21 equal to R2 minus R1, here R1 minus R2. Now both are put in here, so I get a final value. So R12 we get R2 minus R1, R2 vector minus R1 vector, and R21 we get R1 minus R2 vector plus R1 minus R2 vector. So R1 cancel, R21 cancel. Similarly we get K Q1 Q2 by R squared and 0, 0. So finally we say that if F12 plus F21 that is equal to 0 and F12 equal to minus F1. They also satisfy Newton's third law. Every action there is an equal and opposite reaction. Satisfy the Newton's third law. If both charge are like charge or unlike charge, also they satisfy the Newton's fourth law because the force is a vector quantity. Okay, that's very important. Force is that a vector quantity. Either attractive. Here the force is this force to force. If both are in like charges, so that is a like charge means a repulsive force. Repulsive force. And there is unlike charge. These forces are attractive force. These forces are attractive force. Okay. So I think there is a satisfy Newton's third law. Now calculate force of multiple charges. If there is only one charge due to the two charges, okay, Q1 experiences force due to Q2. If Q1 experiences force due to multiple of charges, here the some charge experiences force due to other charge, other one charge, the system now consider the multiple charges. Suppose the forces between multiple charges. So, what is the multiple charges say? Say that there is a suppose consider two charges. Suppose Q1 here. Say that that is a positive charge, and that is another charge plus Q2. Another charge. Suppose say that is a Q3. And that is the origin O. Okay. So position vector of Q2 charge is R2 is a positive charge. That is R1, R3. Sorry, that is R1. So calculate Q1 force applied a Q1 force experienced by Q1 due to Q2 and Q3. Total force. Okay. Calculate the force. Calculate total space is needed. Calculate total force on Q1 due to Q2 and Q3, and there is more charges present. So Q1 experiences force due to Q2, that is 1, 2. So displacement vector here is R1, 2, and Q1 experience force due to Q1 charge experience force due to Q3, that is R1, that is F1. So resultant force, so if vertically added, this is the resultant force F1. Say, how do you calculate the resultant force F1? So very important, if you have multiple charge, so they obey superposition. They satisfying superposition theorem. So just simple algebraic addition. Okay. So if vector additions look like this. So here now draw a perpendicular from F1 to that, and that line is parallel to that line. So that is F13 vector. F1, F12 and F13. Say that is a triangle here ABC. Now apply vector triangle law ABC. So clockwise is positive, anti-clockwise is negative. Okay. We satisfied this or choose that. So F1 is clockwise is positive, F13 is negative, and F3 also negative. Zero. So finally get F, sorry, F3, what is it? F13, and that is F12, sorry, that is F12. So F1 equal to, that is F12. 12 F12 plus F13. Just simple addition. If I use the vector algebra, this clockwise is positive, anti-clockwise is negative. So we get a final, there's a vector algebra, just addition. So that is F1, that is equal to some constant K, Q1, Q2 by R12 square, R12 cap, some constant K, Q1, Q3, R13 square, R13 cap. If a more charge are present here, suppose the continuous. Now K common, okay, and here is the R Q1 also common, sorry, Q1 common, Q2 by R12 square, R12 cap plus Q3 by R13 square, R13 cap, and so on. So it's algebraic addition. And finally we get some value of K constant 1 by 4 pi epsilon naught fixed for all values. Q1, choose a summation sum I starting from 2 to n. So Qi by Q R1I square and R1I cap. That is the total force experienced by Q1 charge. If a multiple charge present, is a 1, 2, 3, 4, there are multiple number of charges. The simple algebraic addition. The simple algebraic addition. Simple algebraic addition. Okay. Clear? the concept. So what is force and how to calculate the force? So next class we discuss what is field. Okay, field, and there is some basic type, a triangle, some calculate force, total force on charge, various type of shape, a triangle, rectangle, square. Okay. So today end the class here. Thank you.